Modern enterprises generate millions of data points every day. For an internal audit team, the core operational challenge is providing objective assurance that the systems processing those transactions are actually working. Trying to manually test every physical asset or paper document across a global organization is financially impossible. It would take a lifetime to complete a single audit cycle. The solution is audit sampling. By extracting and evaluating a strictly controlled subset of data, auditors can mathematically infer the health of the entire operation. But this mathematical projection only holds up if the selection mechanics precisely match the specific objective of the audit. Select the wrong sampling method, and you introduce fatal sampling risk. The assurance conclusions become void, leaving the organization exposed to hidden operational threats. To eliminate the guesswork from this process, we have to build a rigorous decision matrix to identify the optimal selection strategy. The first node in our matrix forces a choice between two paths: judgmental and statistical sampling. Judgmental, or non-statistical sampling, relies on an auditor's experience, intuition, and targeted risk assessment to select items. This method is often used to test a specific hypothesis, where an auditor selects known high-risk transactions to prove that a control system is weak. Because the selection is biased by design, you cannot mathematically extrapolate the results to the total population. The errors discovered only represent those specific items. Statistical, or probability sampling, ensures that every single item in the population is assigned a known chance of selection. This mathematical objectivity allows the auditor to accurately project their sample findings across the entire enterprise. If the audit objective requires providing assurance on an entire unknown population, statistical sampling is the only valid path forward. Following the statistical branch down, we hit the next decision node, identifying the specific phase of the audit. Internal audits involve two primary phases that require completely different underlying mathematical logic: tests of controls and substantive procedures. Tests of controls evaluate the operational effectiveness of a specific safeguard over a defined period. Controls testing requires attribute sampling. You are checking for binary yes or no deviations, such as whether an authorized signature is present or absent. Substantive procedures are designed to detect material misstatements directly within financial amounts and disclosures. Variable sampling measures the actual monetary variance and calculates the specific financial impact of every detected misstatement. International Standard on Auditing 330 makes a strict distinction here. Applying substantive monetary threshold logic to determine the sample size for a test of controls results in a mathematically invalid sample. You must align your mathematical logic, attribute versus variable, with the exact testing phase before you begin pulling data. Once the phase is set, we reach the final tier of the matrix, the mechanical execution of extracting the data. Random number sampling is the most direct approach. Using a generator, items are selected with total objectivity, giving every data point an equal chance of review. For unnumbered records or continuous processes, auditors use interval sampling, selecting items at a fixed cadence. Both methods assume the population is easily accessible and uniformly organized. But populations are often geographically or logically dispersed, making simple random sampling too costly to execute. To solve this logistical dispersion problem, auditors use a method called cluster sampling. The auditor randomizes at the macro level, selecting an entire location or a specific file cabinet, and then tests the contents within that cluster. While effective for logistics, these baseline tools assume the underlying population has a relatively uniform variance. Real-world financial data is often heavily skewed by massive outliers and extreme values. If you run a simple random sample on a high-variance dataset, you risk missing the low-frequency, high-value transactions entirely. Stratified sampling forces order onto this chaos by separating the population into distinct horizontal strata based on transaction size or value. This allows auditors to isolate high-risk items for 100% examination, while applying efficient random selection to the rest of the population. When conducting substantive testing on financial balances, auditors can take variance management further with dollar unit sampling. In this model, the sampling unit becomes the encompassing dollar itself, rather than the encompassing physical transaction record. Because larger transactions contain more individual dollar units, they possess a higher probability of being selected. Stratified and dollar unit sampling are engineered to neutralize extreme population variance, ensuring that material misstatements cannot hide among millions of smaller transactions. The path from the initial audit objective down to the final selection mechanic is a deliberate, mathematically governed process. The validity of any audit finding is inextricably tied to the integrity of this selection architecture. If the logic fails at any node, the final assurance is compromised. Modern audit software now allows teams to test 100% of digitized transactions in seconds, bypassing traditional sampling for certain datasets. Automation has limits. Whenever an audit requires verifying a physical inventory or evaluating a complex internal control, manual intervention is required. As long as organizations rely on physical assets and human actions, precise audit sampling remains the bedrock of objective assurance.